Welcome to our second part of the metric measurements review notes. And so this time you'll be filling out the second half of the chart that you began when you watched the first video about this stuff. So just to review, we talked about length and mass and volume first, and we did that because they're the most basic measurements. And so now we'll apply a couple of those to these other measurements that you've learned before, and you'll be using some more this year in earth science. So the first one that we're applying is density, and I know that you've done a lab based on density before, and the definition is that it measures how much mass is contained in a given volume. Basically, that just means how much matter is crammed into a certain amount of space. Some matter might be spread out and it might take up a lot of space. Some matter might be really pushed together, kind of like sardines in a can, and that determines how dense an object is. The units that we use for density depend on whether we're talking about a liquid or a solid. For liquids, we'll tend to use grams per milliliter, and so we have these two different units because of the formula mass divided by volume. So the mass goes with grams, the volume goes with the milliliters. And if we're talking about a solid, we'll do the same type of comparison of these units. Again, grams stays the same because mass doesn't depend on the type of object that you're measuring. The unit will stay the same no matter what, but the volume part of that unit will change. So for solids, we talked before about how typically it'll be centimeters cubed because that easily transfers from one to another. Remember, centimeters cubed equal milliliters. So 1 centimeter cubed is the same thing as 1 milliliter. So again, the formula is mass divided by volume. And I know in the past your teacher has told you that you can use the formula for that, but this year, because this is actually coming down from the high school, you're expected to know this without me giving you the formula. So this is something that you will have to memorize, and I just want to tell you ahead of time so that you're not panicking someday when we take a quiz and you're not given the formula for this. You're going to have to know it. To measure density, the objects that we need are going to be triple beam balance, or the digital scale if we're measuring the mass part. And then in order to measure the volume, we might need a graduated cylinder, and we'll talk about water displacement in class and how that works if we have a weird shaped object. If it is an object that you can measure the different dimensions easily with a ruler, we'll use that to get the solid volume. Temperature is super easy. You've been using temperature measurements for a long time. You probably didn't even notice it when you were a kid. But when you're trying to determine what clothes to wear outside based on the weather, you're basing it off of the temperature outside most likely. And so definition is that it measures the amount of heat in an object. And we got pretty specific in physical science before, so this is a more basic version of that definition. In science, typically we're going to see degrees Celsius as the unit when we're talking about the metric system. And I've shared before in class how in other countries they'll use degrees Celsius. So if you ever get a chance to see a weather map for a foreign area, or if you're ever in a different country and you see a thermostat reading that says something like 17 degrees Celsius, just know it's not the same thing as degrees Fahrenheit. It's a different type of measurement to say the same thing. You don't really need a formula for temperature unless you're talking about converting between Celsius and Fahrenheit. So that, you know, when you see 17 degrees Celsius, you would understand what that translates to in Fahrenheit. But you don't have to know that formula right now, so we're going to hold off on that. The equipment, obviously it would be a thermometer, and that would help us measure temperature. And the last thing that we need to review is weight. Weight is a type of force that depends on the gravity of an object. So if we were able to travel from Earth to another planet or to the moon, the gravity depends on the size of that object and how far away it is from Earth or from you. And so in this case, if you're standing on the moon, your size relative to the moon is very, very small. So the moon's gravity would be felt on you. But you would weigh a little less than you are weighing on Earth because the moon is not quite as big as Earth is. The units that we use for weight in science are newtons, and the formula that we use to measure it would be mass times gravity. And just something that you've had to know before is that gravity's gravity on Earth is 9.8 meters per second squared. So if you were to fall out of a plane, that's how quickly you would fall, assuming there was no resistance from the air and the wind and everything. The measurement or the equipment that you need for the measurement of weight would be the triple beam balance. And again, if you want to use a digital scale for that too, you can. So that is it for these notes to review metric measurements. Again, this is nothing new, it's all review, and this will help us throughout the year as we use these words. I just want to make sure that we're all on the same page and we're ready to go. So I shall see you in class, and you have a good evening.